And now you can ask some questions to clear your doubts. Yeah, come out with your questions. Whatever you are studying till now in digital electronics, any question regarding those things, anything. You can write in chat or raise your hand. Let's see who comes out first. So last day you are all very enthusiastic with your questions. So I expect that today also there will be quite a few questions like that. So is a CR here by Vaibhav? Vaibhav is still not joined. Let me ask a question. How the other faculties are taking their classes? Are they taking during the live session?
Yes.
So, they are using the whiteboard or something. They are using is sharing their screen and writing on it like that.
Yes, sir. There's sharing screen, whiteboard, and PPTs also.
Okay. Hmm. No one is sending like what I am doing, like pre-recorded lectures. Is anyone doing like that?
Pramod sir is doing that.
Okay. And then he is engaging during these hours with interaction.
No, sir.
So there is no way to interact with him. Like is just he must have provided something, some way
Not
to
He
right
said
now.
interact.
he'll keep class if it's required, like for doubt
Yes.
session and all.
Yes.
Okay, okay. So you have to approach if there is doubts and all, then he will arrange a class.
Yes, sir.
Okay, okay. Yes. So these sessions are for doubt clearance. You please start with your doubts. Don't shy away from them. So there has been lot of things has been covered. Now new lecture topics are also introduced, the logic gates and all, na? So if you have studied those, if you have gone through those videos, some queries you might have. So I guess 45 people are going to attend this session. So the number is not increasing now. 46 it has become. Anyway, so any question, any doubt, please write down or you speak out, raise your hand. You know the drill. I don't have to remind you again and again. So I am here. You can ask any question. If you don't have much to ask, then I will have a sort of a brief rounding up of what has been covered. So this week you were submitting for the signed numbers, the tutorials, right? You were submitting for the signed numbers, na? So
Yes, sir.
now this week you will get the tutorial for the logic gates. And so how we studied this thing, entire digital electronics, how we study, we try to first understand the significance of number systems, because we are going to use a different number system than we usually use in day-to-day life. In day-to-day life we use the decimal number system, where the value and the number is basically the same, like identical. Okay, so however when we go to different other number systems, then the value and the number are not identical, so we have to decode the value from the presented number. So there, all these ideas, all these concepts about representation, information, then abstraction, all these things come into picture. So all these ideas are not actually not required for passing the subject as such, because they don't come into the syllabus of the subject. However, since we are dealing with certain concepts as they come in, I I like to cover a bit here and there about the concept, so you get a more deeper understanding. Some of you would definitely gather that understanding and would probably help you to see even other subjects. These are very general concepts, very useful concepts, which you can which actually change your view in life in general. Also it can change your perspective in life, so you would try to see into things about what is actually present, and what is the abstraction that we are the abstract knowledge that we are gathering from the physical objects. So all these different things are there. So with those understandings, actually then we move, then what we actually developed finally is that we have different number systems, and we are now at a position to use these going ahead. And then we fixed on the binary number system, because we can build machines where machines with switches as their basic elements, and the switches will have two different states only, and we can denote these states with 0 and 1. And once we denote them as with 0 and 1, basically whatever physical switch on off things are happening within that machine is basically some play of zeros and ones. So now since we know binary number system, so we know how to play with zeros and ones, so that game is known to us how to. So any number, any value, any quantity could be represented. However, there is additional things that could be done, because the logic system is also based on this sort of dual ideas of true and false, right and wrong. So this sort of logical variables appear, and there is a separate entire set of maths which is covering the logical variables. Logical variables are called the Boolean variables, or Boolean because there is only two variables present, and we can represent them with 0 and 1 again. So however, we need to understand that the 0 and 1 in the Boolean algebra is not a number, it is simply an object, another representation of true and false with 0 and 1. And the operations therein are like the logical operations, which are AND, OR, and other operations like NAND, NOT, NOR, XOR, XNOR. These sort of operations can be done between two Boolean variables as well as several Boolean variables. We have studied only two Boolean variables because that is the basic, and with the help of that you can actually extend the idea if you are given several Boolean variables also. So that is the Boolean algebra. So even the logical operations, so some decision making if needs to be done, that is a logical operation. So when we make some decision in our mind, we are also doing a logical operation. So we try to understand what is the context, so what has happened, so and if this has happened, then this sort of thing should be done, or otherwise or else this sort of thing should be done. So this is some logical thought which is happening in our mind. So this sort of operation can also be done by the computer, by the machine, which is comprised of switches only. So logical operations as well as arithmetic operations, both these sort of operations can be handled by the physical computer, which is nothing but a set of switches arranged in some definite way. And what definite way the switches need to be arranged, that we saw that during logical operations, whatever the logical operations are, which are the and or not, these operations, we can ideate a gate around it. So like AND gate, so two variables entering that gate would give us the operation of logical AND. Now that idea, even the gate idea is an abstract idea, but now that abstract idea has to be physically implemented. So now we are using the actual physical switches to implement the AND gate, OR gate, NOT gate, like that. And we saw the CMOS transistors, how as the circuit of the CMOS transistors. Only that physical implementation we would see in the course of the subject. However, there are many other different types of physical devices that can be used as switches. In earlier days, there were mechanical switches being used. Then vacuum tubes had been used. Then transistors came in, and very basic transistors like BJT were being used. Then slowly these transistors also got developed, and CMOS is getting used nowadays, and other transistors can also be used. So when you look into the data sheet of a particular IC chip, which is a chip with many such gates, suppose AND gates. So there is a IC chip of AND gate. There are several AND gates in that. So that data sheet will give you all the information regarding the what is used to which sort of transistors are used to make this chip, what are the different voltage and current ratings of those transistors. All these different things will be given in the data sheet. So reading the data sheet also important. So one small lecture has been devoted to that, how to understand the data sheet, what information you can gather from the data sheet. So now actually we are in a position to understand that there is a computer which is a physical machine comprised of switches only, and how these switches etc arranged within the computer, right now we are not discussing that, and we will not discuss that. Okay, but what is the elementary constituents in the computer, that we have come to understand. Those are transistors only. However, we are not looking into the level of transistors, we look a level up, which is the level of gates. At the level of gates we would work. The gates are comprised of transistors. However, we would look into our basic element as these gates. Now with these gates we will start working. From the next lecture onwards, we would use the gates to form different complicated circuits. We already drew up some circuit in the last lecture. If there is a Boolean expression which is a logical expression, so how we can make a logic gate circuit for that expression. Next lecture onwards, what we will see is that so it seemed that we came to know about numbers, then suddenly we left the numbers and we started discussing the logical variables, and now we are at a position where we can work with the logical variables using the computer. But what about numbers? What about the numbers? How the computer handles the numbers? So we would see what circuits can be developed. So the arithmetic operations can also be done using the gate circuits, using the logic gate circuits. So the logic behind the arithmetic operations. The arithmetic operation is an algorithm, so there is definitely a logic behind it. So that logic would be implemented using the logic gates. So now we will be at a position where we are comfortable in or we are certain that the computer will be able to do both computations as well as decision making as well as logical reasoning. So both computations and logical reasoning can be done by the computer, and actually both of these are quite synonymous in character, because ultimately the logical circuits are what are doing their job. So you can call them computations, everything can be called as computations, everything can be called as logical decision making. So it is like a synonymous thing happening there. So there, at this position we have reached so far. So till now, if you have any confusion, because there are several concepts which are different, like they appear as the same but they are distinct. So where is the distinctness and where is the similarity? This is what actually makes us knowledgeable. If we can understand what is the difference and what is the similarity, that gives us the knowledge about several the things that we are actually comparing. We can distinguish between them and as well as understand what is the underlying similarity. This is how knowledge develops, also scientific knowledge develops. Yeah, anything, any questions? Okay, so if you don't have much questions, then I guess we can do a wrap up probably. You can again go through the lectures and see if you have any doubts or anything, and you try to use the theorems are there. The Boolean theorems are important to understand. You have to memorize some of them also, but if you look at them uh, a certain number of times, they are very easy to remember, but then how to apply them, that is also important. So you have to practice applying the Boolean theorems. Their important thing is to, first step should be, if there are brackets, you open up the brackets, and then the next step is to see whether you can apply consensus theorem. These two you remember. After that, any theorem you apply in any order, whatever you see, however you can minimize them, you can do it. You can keep on doing it. But first, you look into these two things. You open up any brackets, and then you apply the consensus. So consensus must be applied at the very beginning. Otherwise, there might remain an extra term, additional term, which you will not be um, able to simplify later on. Okay, so I have talked quite a lot, and since you are not having any query, so I think it's best to end the session today, and Thursday we'll see if you have further queries or not. So I am ending the recording, and see you again on Thursday.